Hi everyone. So in this video we will be studying about the ECG paper itself, the calibration of the ECG paper. By that I mean to say, especially in this video, we will see what does 1 millimeter mean in terms of width as well as height. Okay, so the ECG paper consists of parallel vertical and horizontal lines forming small squares which are 1 millimeter wide and 1 millimeter high. Every fifth line is highlighted and is darker than the other lines, thus defining a larger square of 5 small squares vertically and horizontally. So if you see here carefully, after every fourth thin line we have a thick line, and this constitutes one big square, and these small squares obviously are small squares, right? So the width of the ECG paper represents the time. Now the width is actually going to represent the time. This is the time, right? Every millimeter or one small block is equivalent to 0.04 second, right? So it represents 0.04 second. Now the question arises, why does 1 millimeter represent 0.04 second? Why not any other timings? The reason for that being that the standard ECG is recorded at a paper speed of 25 millimeters per second. So now if you use this and try to find out the time taken by 1 millimeter, you will find out that it's going to be 0.04 seconds. So here is a little conversion. If 25 millimeter contributes 1 second, then 1 millimeter is 1 by 25th, that is 0.04. So this is where you get 0.04 second. So the width of the ECG paper is going to represent the time, and 1 millimeter is equal to 0.04 seconds. Okay. And every highlighted line containing 5 small square is equivalent to 0.2 seconds. So this is one small square, this is second, third, fourth, fifth. And if each small square is equal to 0.04 second, then 5 small squares will be equal to 0.2 seconds. So this is where this number comes from. Okay, so this was about the width. Now coming to the height. Now the height represents the voltage. We talked about the width was the time, but the height represents the voltage, right? Because the height is standardized to give a deflection of 10 millimeter per millivolt, every small square is equivalent to 0.10 millivolt. So the number that you see here, that is 0.10 millivolt, so the number that you're seeing here, how did we get this? This is how we get this. We know that the standard ECG is recorded at a paper speed of 25 millimeter per second, and at the same time it's made and calibrated in such a way that 1 millivolt will give a vertical deflection of 10 millimeters. So if 10 millimeters constitute 1 millivolt, 1 millimeter will constitute obviously 0.1 millivolt. This is where we get this number. Okay, and two big boxes will constitute 1 millivolt. Okay, so the width will represent time, the height will represent the voltage, and the ECG is made up of small squares, and each small square is 1 mm of width or height, or the side is 1 millimeter. When we talk about the width, each millimeter constitutes 0.04 second, and when we talk about the height, each millimeter contributes to 0.1 millivolt. So that is all about it. Thank you.